So first step, real simple. Let's just get rid of the constant here. We've subtracted the 12. We still have, and please make sure you include everything, 3. We still have the absolute value bars. But now it equals positive 12. Now I want to stop and remind everyone, the very first idea that was thrown out for what we should do at the beginning was, let's do distributive property. Because absolute values look a lot like parentheses here. But my response to that was, there is actually no distributive property in this entire problem. So keeping that in mind, there's no distributive property in this entire problem. I told you in the last example, you can't move these things around until you've removed the absolute value bars. Does anyone have an idea of what we should do next? Robin? You mean the 2z and 9? Okay, I do want to isolate the 2z and 9, and how would I do that? What's in my way right now that I would need to get rid of? The 3 definitely needs to go. I need to get rid of the 3, and I need to get rid of the absolute value bars. We'll have to do them in separate steps, but let's start with the 3. To get rid of the 3, you have to think, well, what's happening here? If there is a number right next to something, what operation is that? It's multiplication. This is 3 times the absolute value of all this. So let us undo that multiplication with division. Divide both sides by 3. The 3's will cancel. I still have absolute value bars, 2z plus 9. I would so buy that candy if they made it. Absolute value bars. And 12 divided by 3 is 4. Now it is turned into what we have in the last example. There are absolute values on the left. There is a number on the right. We are now ready to split this. If I can make everything in the absolute value equal 4, it would give me an absolute value of 4. If I can make everything in the absolute value equal negative 4, then the absolute value of that would still be 4. So I will now solve for both scenarios. And this is just a two-step equation. So I would subtract 9 on both sides of both of these. That would give me 2z equals 4 minus 9 is negative 5. Or 2z equals negative 4 minus 9 is negative 13. I'll divide by 2 on both sides of both of these. And I now have that z is equal to negative 5 halves, or z is equal to negative 13 halves. And those two fractions become my new solutions.